So hi, as she said, my name is Terry Schussler, Senior Director, Next Generation Devices at Deutsche Telekom, which means I lead research and business development around wearables and what we call nearables, products that live on or near your body. Imagine designing one immersive XR experience and deploying it seamlessly across Apple Vision Pro, Samsung Galaxy XR, and the web. Today, we're going to explore how AI and new product workflows make that possible. And I promise, by the end of this talk, you'll understand why the future of XR development isn't about learning 5 new development platforms. It's about learning how to talk to AI about what you want. But first, some vibes. Before we dive in, I need my beer. Beer me, please. Thank you. And while we're getting set up here, I'd love everybody to move up to the front if you want to hear properly or see better. Let's be friends. And also, second, I want you to scan the QR code. It'll take you to the entire presentation and all the resources that I'm going to show you and talk about. And third, and I say this with all the love in my heart, put your phone down, damn it. You don't need to photograph these slides. I took the time to make it so you can download them. Just listen, engage, and let's have a conversation about the future of XR. Okay, so the most important tool you have is your imagination. Vibe coding is a natural language-driven, AI-powered approach to building and refactoring code. Here's my big insight. It flips the ratio. Thomas Edison said genius is 1% inspiration and 99% perspiration. I think vibe coding is 90% inspiration and 10% perspiration. You focus on your vision, what you want to build, and AI handles the repetitive scaffolding, the boilerplate, the cross-file refactoring. The profession has evolved. We used to call ourselves hackers, people who could cobble things together. Then prompt engineers, people who learn to talk to AI. Now we're becoming vibe coders, creative problem solvers who stay focused on what matters, the experience, the story, the interaction. So XR is really cool, but it's hard to develop. The reality is that XR platforms today are siloed. Different languages, different tools, different hardware interfaces. You're duplicating effort, slowing iteration, reinventing wheels across visionOS, Android XR, and the web. Vibe coding solves this by making intent-first development possible. Instead of saying, I need to write Swift code for this interaction, you say, here's the experience I want. Here are the constraints. Go figure out the code. And AI handles that translation. What does vibe coding actually mean? It's natural language flowing directly into code, scenes, tests. You're using integrated development environments with agents built in, cursor, anti-gravity, lovable, where you describe what you want, and the AI proposes architecture, scaffolds the code base, and refactors across multiple files. The upside is you focus on vision and interaction design. The AI handles scaffolding and refactoring. Programmers get superpowers. You can do 10 times more work in the same time. And here's the thing, not everyone using vibe coding needs to be a programmer. If you can describe what you want, vibe coding can help you build it. We interrupt this message because we need to be honest about the hype. There's a gap between what people claim AI can do and what actually works. The hype says, build a game in 1 prompt. The reality is you're still manually fixing spawn points. The hype says, AI does all the coding for you. The reality, you prompt, you debug, you reprompt, you clean up. AI handles the scaffolding and the grunt work, but you're still steering. The hype says anyone can ship finished products without coding. The reality is tool chains still need someone who understands how things fit together. Technical debt accumulates faster. You need to plan refactoring strategically. Here's what vibe coding is actually good for. Simple to medium complexity projects built on modern, well-documented frameworks. It's fantastic for prototyping, iteration, and moving from idea to working code quickly. What it's not good for is mission-critical systems or massive systems at scale, or anything requiring deep security hardening. And honestly, those projects probably need human experts anyway. Let me introduce 3 main tools that you'll use in a vibe coding workflow. Think of this as your toolkit. Each tool is optimized for different jobs. Lovable is web-focused. It works best with React, Next.js, Node.js, Supabase. If you're building WebXR with 3.js or Babylon.js, Lovable excels. It gets you from here's an idea to here's a working prototype faster than anything else. Cursor is a deep repo-aware IDE. It understands Swift, C#, Python, and lots of other languages. It's perfect for single project deep dives where you're refactoring your visionOS code base or deep diving into Unity. It works seamlessly within Xcode, Android Studio, and VS Code. You're not using a new environment, you're augmenting the tools that you already know. Google Anti-Gravity is something different. It is an agent-first environment where multiple AI agents can collaborate. You tell Anti-Gravity, keep these 3 targets in sync: visionOS, Swift, Kotlin, Android XR, and WebXR. And its agents handle the mechanical translation, the refactoring across repos, the verification. It's not just an editor, it's a platform where coordination happens. The key insight is vibe coding isn't about one specific tool. It's about a mindset. You describe what you want in detail. You let AI propose code, architecture, and assets. You steer with prompts until you're satisfied. The tool is just a vehicle. Now, let me take a moment to show you a demo of a vibe coding project. Oh, if I can, switch windows here. Oh, that's interesting. There's some blocker here that I have not ever seen before. Let's do this. So bear with me. Okay, so here is a project, which I'll reload from scratch, I built with Lovable called Travel is for Sharing. And the idea behind this project was just to explore what I could do with Lovable to build a user experience centered around images that I had captured from visits that I've done to different cities, business trips or personal vacations, and to show this idea of visualizing all of these over time and geolocating them on the Earth. And some interesting things about building this application of Lovable is I only touched the code once for one stupid little thing, but only one time. This entire project was built without my ever actually touching the code, basically. And one of the things that I wanted to point out about vibe coding that I want to highlight here is localization. So I started building this application in English, and I said, why don't I actually make the whole program localized in several languages? And so many, many languages, and it was really easy to do. Because once I architected, and I'll talk more about how to do this, the application prompt so that I could get it to localize in one language, it was very easy for me to add additional languages, even right-to-left languages. So this is like a superpower that a lot of people don't realize you get out of vibe coding. Now this project has, a fun little interactive globe. And one of the things I wanted to do is I used an image from NASA to map the surface of the globe, but I wanted to get a better detailed map, one I could zoom in on it. And so I used vibe coding to integrate Mapbox as a platform. So now I have a satellite view of the Earth that's done with Mapbox. And then I thought, wouldn't it be cool? Of course, I can scroll around and double-click to zoom in. But wouldn't it be cool if I could use voice as an input mechanism? Let me allow that. And take me to the Grand Place in Brussels. And if it works right, my internet connection. Try it again. Take me to the Grand Place in Brussels. Yeah, sometimes, Murphy demos don't always work. There we go. Zoom all the way in. So with this, I built a voice interface to allow me to control the Mapbox UI. Again, vibe coding. I didn't touch any code, and I didn't learn any new APIs, and I'll actually show you a really great set of strategies, including download document, that explains how you can build prompts for your IDEs, for your AI tools, that will allow you to get to an outcome with an API that doesn't know anything about. So I'm just using this as an example to show you the potential. This is a very deep application, has a lot of features. But let's go back to the presentation and continue from there. OK, so now let's talk about the real problem XR developers face, juggling multiple tools. You've got Xcode for visionOS, Unity for rendering, Android Studio for Galaxy XR. Each one has its own files, its own logic, and they're all trying to express the same experience. Agentic AI keeps a big picture view of your repo. It understands how files relate across Swift and Kotlin. It can identify all your RealityKit interactions in the visionOS project and automatically propose the equivalent using Unity XR Interaction Toolkit or Android XR APIs. Instead of manually discovering what interactions you have, how they work, and translating them by hand, work that takes days, agentic tools can generate multi-file refactors that touch dozens of scripts in one go. Here's the game changer. AI doesn't just translate syntax. It translates concepts, anchors, gestures, gauge tracking, teleportation. These are platform-independent ideas, but each platform implements them differently. AI understands that translation. It takes what was tedious, manual, error-prone discovery work and turns it into an automated, repeatable workflow. All right, do it that way. Now, of course, I'm getting all kinds of weirdness here. Sorry. Yeah, try that again. Oh, always some. There we go. Back up here. OK. So before you write a single line of code, you architect. This is where you do the most invaluable thing in your project. Starting with Claude. Claude is the best reasoning tool, the best planner. Use it to define your modularization strategy, separating core logic from platform adapters from assets. Identify platform-specific constraints early, input models, rendering pipelines, performance targets. Create a phased breakdown, an MVP for one platform, port to the next, optimize. Document assumptions and unknowns so you don't carry them through to production. Here's a real prompt that you could give Claude. It's actually a simple version of one I'm going to give you to download later. I'm building an XR experience for Apple Vision Pro and Samsung Galaxy XR. Help me design a modular architecture where core interaction logic is platform agnostic. Rendering is abstracted and input is mapped to consistent verbs like select, grab, teleport. Create a phased plan. Phase 1 is visionOS MVP. Phase 2 ports to Android XR. Phase 3 adds WebXR. For each phase, tell me what code is new versus reused. Now, this is a simple version, but Claude will think through this carefully and give you a real roadmap. I am having some weird sequencing issues. All right. ChatGPT versus Claude versus Gemini. Spoiler, you're going to need them all. Different models have different strengths. Know them and know when to switch. Claude Sonnet is your planning and architectural model. It is the best reasoning, the largest context windows, 200K, and the most nuanced understanding of complex problems. Use it first. ChatGPT is fast, it's reliable, it's great for interaction and coding, it knows the web well. Once you've got your architecture locked, ChatGPT can scaffold code quickly. Gemini 3 Pro integrates deeply with Google tools, especially anti-gravity. If you're using anti-gravity for cross-platform sync, Gemini is your natural partner. Fast reasoning, good for cross-platform refactoring. The smaller models, Claude Haiku, GPT-4o Mini, are fast and cheap. Use them for refinements and follow-ups. They're great for iterating on code once you've got the big picture figured out. The workflow, start with Claude for design. Switch to ChatGPT or Gemini for rapid coding. Use smaller models for special case work. Now, everything's not working. There we go. Okay. I know. It's crazy. Okay. Now it's just my headset scripting crazy. Okay. So let's go to the next slide. All right. So here's a real vibe coding project flow. Phase 0 is planning. Use Claude to create your architecture and phased roadmap. This takes time. Maybe a few prompts, maybe a lot of prompts moving back and forth, but you're building a plan that will carry you through the entire project. Phase 1 is scaffolding. You use Cursor plus ChatGPT to generate your initial code base. You're not starting from scratch. You're iterating on what Claude designed. The code base starts to materialize. Phase 2 is interaction. And here you're using anti-gravity plus prompt refinement for cross-platform refactors. You've got visionOS code working. Now you're bringing the same experience over to Android XR. Anti-gravity is orchestrating that across repos. Phase 3 is polish. You're profiling. You're looking at performance. You use Claude or Cursor to generate optimization prompts. This method is slow. Suggest an optimization that might be maintain the interaction feel. Phase 4 is maintenance. New APIs come out. Platforms update. You're using agents to periodically review your platforms and keep them in sync. Maintenance becomes less of a chore and more of a scheduled sync. The key, each phase has a purpose. Each uses the right tool. And together they move you from idea to maintain cross-platform product. Now, I'm just going to briefly show you, if everything works okay, another example of how far you can take this. So I built an application in Lovable, which is like a vibe coding pre-generator that interviews me to get me to describe a particular experience that I want to build in XR. And so I didn't have time to do a live demo of this, so I just kind of ran a demo so you can see it. But here is the outcome of a conversation I had, a voice conversation, funny enough, with my own voice, talking to myself, which is always a great thing late at night. And here I generated a general sort of summary paragraph description or so of the project. And then my tool analyzes this against a whole bunch of different aspects: domain, target audience, user input methods, target platforms, key features and capabilities, and AI services, development frameworks, and target IDE. And so it also does analysis. It analyzes, hey, you said you wanted voice AI in your mobile app, or your app for art galleries, but people don't want to hear other people talking in the middle of the gallery. Maybe you shouldn't use voice AI or voice input as a modality. And so once I'm all done with that, this tool actually starts to build out lots of information. It builds out a whole marketing plan. It builds out a user experience and a set of journeys with different user personas, a technical plan, an implementation plan. And this is the meat and the potatoes, because this becomes targeting the IDE that I want to use for the scaffolding, a set of detailed prompts that I can generate, or I can export, and then I can feed into the IDE in phases to build it out. And the reason you need to deconstruct this is that you can start hitting what's called the context window limit in these IDEs if you try to stack too big of a complex set of instructions in at one time. So you do it in chunks. And you basically have a working scaffolded project at this point. So this is just an idea that I was playing around with just to showcase the potential of actually using AI tools to drive other AI tools. And it gets very interesting in this sort of meta prompting or prompt chaining, sort of idea. Okay. So here's a challenge for you. AI models have a knowledge cutoff, right? I think the Gemini one is like January of 2025. Android XR released new APIs yesterday while I was sleeping last night. I got a call at 4:30 this morning from somebody I work with saying, hey, did you see the Android show where they showed all these new Google Android XR APIs? I'm like, no. So guess what I was doing this morning? Updating my presentation and showing you how to keep your IDE abreast of the updated information. So the key is, how do you keep reasoning models current with cutting-edge APIs? You use structured artifacts. You create a reference document, not loose notes, but a precision artifact. Include exact class names, method signatures, package paths, code templates. Make it harder for the model to guess than to admit it doesn't know something. Organize that knowledge hierarchically. Layer 1, what should I build? Layer 2, how do I build it? Layer 3, what are the constraints? This layering lets the model follow a path instead of trying to fill in gaps with hallucinations, because that's what will happen if you make it guess. Mark confidence levels explicitly. If a detail is from official docs, mark it with a check mark. If it's inferred, use a tilde. If you don't know, mark it with a question mark. The model can't hallucinate what you've marked as unknown. Index the artifact for fast lookups. Structure it so the model can find, how do I implement this task? Or what's the class for this feature instantly? Less time searching means less time inventing. This is the artifact as knowledge base pattern. When new APIs drop, you can regenerate that artifact from the latest docs and feed it to Claude or anti-gravity. They reason within those constraints. Your code base automatically stays current. One of the things you're going to get to download, and I'll show the QR code again at the end, is I went to Perplexity and say, hey, Perplexity, give me a detailed report on all of the new API features that were revealed by Google in their developer preview version 3 for Android XR. I didn't have time to sit and read all that documentation before I came here to present this to you, so I made Perplexity generate the report. Then I created a prompt for Claude that said, hey, using this information, I need you to build an artifact of knowledge about all of the changes that came in developer preview 3. And those two documents are there for you to take down and take a look at, and you can literally use that artifact, with your own work to get going. Okay, so let's talk about the two main platforms. Wakey, wakey. Sorry. It's one of those things where presentation gets out of whack. All right, so we've got, of course, Apple Vision Pro and visionOS, a premium spatial computing, M5 chip, gorgeous hardware. The developer ecosystem is built around Swift, Swift UI, and RealityKit, a rendering engine designed specifically for spatial computing and spatial content. You get physically based rendering, animation, physics, spatial audio, all integrated neatly into Swift UI views and immersive spaces. Input is eyes, hands, and voice, no controllers. That shapes everything about interaction design. RealityKit with Reality Composer Pro is your authoring environment for scenes, materials, and spatial composition. Samsung Galaxy XR is Android-based spatial computing, co-developed with Google, part of the Android XR ecosystem. You can write Kotlin native apps using Android XR APIs, or more commonly, use Unity 6 with the Android XR SDK and OpenXR. That flexibility is important. C# for coding, same workflows you use on other platforms, but targeting XR hardware. Input is eyes, hands, controllers, and in some cases, you'll see a trackpad. Closer to what mobile and VR developers know. So contrast those. Vision Pro is tight, integrated, hand and eye driven. Galaxy XR is open, standardized, controller friendly. Yet both face the same challenges, hitting 90 to 100 frames per second, managing complex assets and scenes, designing comfortable interactions, dealing with constantly evolving SDKs. I don't know why my presentation keeps hanging, but I apologize for that. All right, so more XR devices are coming, not fewer. XReal just showcased Project Aura, or Google showcased XReal's Project Aura as a new Android XR device. Meta is still doing new devices. There's all kinds of new stuff coming to the table. Companies you've never heard of yet will ship spatial hardware in the next 2 years. If you build bespoke code bases for each platform, you will be rewriting forever. But if you invest in modular architecture, clean separation of core logic from platform adapters, flexible asset pipelines, device-agnostic interaction abstractions you can port to new hardware fast. That's where AI tools shine. They excel on well-structured projects. Hand an agentic system a cleanly modularized code base, and it can adapt your experience to new platforms in days instead of months. The teams that win in spatial computing won't be the ones with the biggest budgets. They'll be the ones with the smartest architectures and the willingness to let AI handle the mechanical translation work. So you've built something beautiful for Vision Pro. Now you want Galaxy XR users to experience it too. Here's the practical plan. Reuse everything you can, the models, textures, audio, sounds. These are the format agnostic assets. GLTF meshes work on both platforms. Spatial audio concepts translate. Don't rebuild assets, port them. Core interaction logic should be conceptually surviving the port, but rendering and input need re-implementation. On Vision Pro, you're using RealityKit. On Galaxy XR, you're using Unity's Android XR SDK or native Android XR APIs. Same experience, but different implementations. AI tools excel here. You give them your Swift Reality system and ask it to translate this to Kotlin Android XR, preserving interaction flow, state management, and performance characteristics, flag any API differences, and suggest workarounds. But again, the cleaner your architecture, the easier this translation. I'm going to beat this point into your head. And because you modularize properly, the change is localized. You're not rewriting the entire code base. Now, input is probably the biggest difference between headsets. Vision Pro has eyes and hands. Galaxy XR has eyes, hands, and controllers. That's a fundamental difference. So here's a solution. Design an abstraction layer. Define consistent verbs, select, grab, teleport, open menu, point. These are platform independent. They're the user's intent. Then implement platform-specific input handlers. Vision Pro input handler maps Vision Pro's gaze and hand gestures to these verbs. And Android XR input handler maps Android XR's combination of hands, controllers, and gaze to the same verbs. A configuration system remaps inputs per device. By the way, this is going to get more complicated with Android XR because you need to factor in all the variants of devices that are going to come into that ecosystem and their capabilities. Now your interaction code talks to the abstraction. It never says check if the user tapped with their left hand or check if they pressed the A button. It says, is the user performing a select action? And then the input layer handles the translation. This is where AI helps too. You ask it, create an input interface defining these action verbs plus Vision Pro input handler and Android XR input handler implementations plus a remapping system. It generates the structure. You tune it. Done. Life should be that easy all the time. So if you want AI to generate good XR code, precision matters. This is as important as architecture. Precision drives this. So here's what works and what doesn't work. Do specify the platform. This is for Android XR with OpenXR. Vague platform targets lead to generic code that works nowhere. Do include constraints. Keep frame time under 11 milliseconds on Snapdragon XR2. Constraints force AI to optimize realistically. Do reference specific APIs and versions. Very important to avoid hallucination here. Use RealityKit's physics component in visionOS 26.2 release candidate, not the older API. Specificity prevents hallucination. Do describe the user experience goal. Users should feel instant tactile feedback when grabbing objects. UX goals shape code decisions. Do request code comments. Remember those? Explain where platform differences appear. Comments make generated code understandable, and they help you work out fine-tuning issues. Don't be vague. Make XR interaction better. Make button faster is meaningless. Better how? Faster how? More intuitive? Less prone to jitter? I don't understand. Don't disconnect from the context. Write code as a prompt without telling the AI what the code should do or what constrains it is dumb. Context is everything. Don't assume the AI knows your code base. It doesn't. describe your architecture, your naming conventions, where the relevant files live. And these IDE tools have special features in them to help you do that. Don't skip iteration. This is the most important thing to me as a programmer and designer. The ability to iterate fast and frequently is really great because you start really getting better outcomes in the user experience. So if the generated code doesn't work, show AI the error. Reprompt with the error message, let it debug, let it figure it out. You can literally copy and paste errors. When I'm debugging WebXR stuff, I take from the debug window and copy and paste the error message straight into my IDE, and it just starts chunking away on figuring out the cause and fixing it. Don't ignore testing. Always ask for unit tests along code. If you don't know what unit tests are, Google it. Untested code is code just waiting to fail. The more precise your prompt, the more accurate AI will be. And by the way, I did a talk at AWE in June, and I have another presentation on the same web page that you could download from there, where I gave a ton of examples of precise XR-specific prompts that you can go and look at and get some ideas from. Ambiguity leads to junk. Know what you want or get there through iteration. WebXR is how you reach everyone else. Any browser on any device, mobile, desktop, headset becomes an XR canvas without App Store gatekeeping. You've built visionOS and Android XR experiences. WebXR lets you give the world a preview or a simplified companion experience, and you don't have to rebuild everything. Vibe coding tools accelerate WebXR. Use Lovable to scaffold 3JS or Babylon.js scenes from natural language. Concept to working demo in hours instead of days. By the way, that travel is for sharing project. I probably spent 30 hours on it, and it's really rich. There's a lot to it. Reuse your GLTF models. Reuse your interaction logic and state management. Avoid the rewrite from scratch tax. WebXR as a fallback means your reach expands dramatically. It's also where AI tools really shine. Rapid prototyping, asset reuse, and iteration happen faster than anywhere else in XR development. Last slide. Here's what I want you to take away. Besides the QR code, which once again is up there for you to scan and download this entire presentation, plus a bunch of sample files and prompts and other things. AI is already transforming how teams prototype, iterate, and debug XR apps. That trend will continue into automated profiling, A/B testing, and live personalization. We are moving into the age of proactive AI and hyper-personalization, and you absolutely need to use AI tools for that. But AI tools are not magic app generators. They're powerful collaborators. Use them to avoid repetitive development tasks. Use them to handle the boring, tedious, dirty work. That frees you to spend energy on what actually matters: interaction design, storytelling, and experience quality. From idea to outcome, focus on rapid prototyping and code scaffolding. Get your concepts working fast. Test them. Iterate. Be fearless. Use any API quickly. I have a document that you can download, which will show you, like I said earlier, how to take brand new APIs and feed them into a reasoning model and make it an instant expert so you don't have to learn. You can just know what it does, but you don't have to learn all the parameters and values and function call tweaks, and it's just a headache. I don't want to do that. I just want to leverage the tech and get the result. Experiment often and try new things. The cost of failure has dropped. The speed of iteration has increased. Take advantage of that. You can move from concept to executable project way more quickly. You can adopt new APIs and tools with ease. You can let AI handle the boring work and focus on building the best possible implementation of your ideas. As I said before, programming skills still matter. Creative skills definitely still matter. You're not being replaced. You're being augmented. It's another way of thinking of where we are now, augmented intelligence. Your job isn't disappearing. It's evolving into something more interesting, more creative, and more focused on the human experience. That's vibe coding. That's the future of XR. Let's build it together.